Okay, now we're going to explore triangles that are not right triangle. Anytime we're given three pieces of information, we can find everything. And remember that if you know two of the angles, then you know all three because they will add to be 180. Okay, the first thing we're going to learn is called the law of sines. And I guess some dead Greek guy who couldn't get a date had a lot of time on his hands, and he figured out that the ratio of the sine of the angle to the side that's opposite will be the same throughout the whole triangle, no matter what your angles happen to be. So we can use this in the cases where we have just one angle, as long as we have the side that's opposite. And then we can have a second angle or a second side, it doesn't matter. And with just that information, we can figure out all of the angles and all of the sides for the whole triangle. Now, you will hear me refer to side, side, angle, or angle, side, side. In this case, we have something special going on, and we'll talk about that later. That would be if I have a side and a side, and then I know that angle, but I don't know the angle between them, or if I have, let's see, angle, angle, side, would be if I know this angle and I know this angle and I know this side. So going around the triangle, the order of the things that you see listed will tell you what you know. Side angle, angle, whichever, okay? And then when we get to the law of cosines, which is the next section, that will be if we have a side, an angle in between, and then the other side, because we don't have the side that's opposite the only angle that I know. Remember, if you know two angles, then you know three. And if you have just one side and two angles, then you have one side and three angles, and it's easy to do. As long as you have an angle and its opposite side, then you can set this up to find out anything you need to know. Also, because these ratios, you're going to take just one set at a time, then these can also be written as the side over the sine of the angle. And remember, it's not the angle itself, it's the sine of the angle. So don't be just putting your degree measurements down there. And for all of this stuff, all of the application stuff, we're going to be using degrees mostly, almost exclusively. So when you're working these problems, whatever you're solving for, put that on top. So if you're solving for a side, use the side over the sine. If you're solving for the angle, you're going to want to use the sine of the angle over the side, and then solve for the sine, and then you'll have to do the inverse sine on your calculator. Yes, you'll be using your calculator for everything in this chapter. All right, let's put this stuff to work. First, I want to always draw a triangle. It will not be to scale. I'm going to go around ABC, and then the sides opposite the angles have the same name, and I use lowercase letters. Now we're told that this angle is 50 degrees. This angle is 110. That means I know the third angle. 110 and 50 is 160. That makes this 20. You see it's not to scale, right? So I know C is the angle 20 degrees. Make sure that those add to 180. Now I have this angle B and I have side B, which is 20. Don't get confused with the angle. So I have an angle and its opposite side, and I can use that to find these. As a general rule, keep in mind that you really do want to start with your largest ones first. And remember again that the larger angle will be across from the larger side. The smallest angle will be across from the shortest side. So the longest side in this triangle is 20. I got to make sure that my other two sides are smaller than 20. Now, A is bigger than C, so I want to solve for side A first. You'll see why later. So A is to the sine of angle A as B is to the sine of angle B. So A will equal 20 times the sine of 50, just multiplying both sides by sine of 50, over sine of 110. Stick that in your calculator and you can get A. Once I plug everything in, I get 16.3 for A. Now, remember, this is not a right triangle. You never, ever, 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 ever use the Pythagorean theorem. That only works if you have a right triangle. I need to give myself a little more room here because I have something else to solve for. C is to the sine of angle C as B. Always use the stuff that's given in the question as much as possible. If I used A and the sine of angle A, that would be an estimation. 20 is 20, it's exact. So usually you want to use the stuff that you know to be true. Multiply both sides by the sine of 20 to solve for C, and you're just going to stick this in your calculator, and I'm going to get 20 times the sine of 20 divided by the sine of 110, and I get 7.27. I'm going to say that that's 7.3. And now double check. Your smallest angle is across from the smallest side. Your largest angle is across from the largest side. All right, next problem. We want to draw a triangle just to keep track. A, B, C, A, B, C. Yours doesn't have to look like mine. Just make sure that the side is opposite its angle. Now, we are told that this is 38. This is 102, obviously not to scale. So what is the other angle? 102 and 38 is 140. So this is 40. All right. Use what you know. 20 is to sine 38 as, let's start with the biggest one. B is 120. So side B is to the sine of 102. So multiplying both sides by the sine of 102, B will be 20 sine 102 over sine 38. And then C will be 20 sine 40 over sine of 38 for the same reason. So on my calculator, 20 times the sine of 102 divided by, and I hit an equal sign. So you need to make sure that you practice with your own calculator and learn how it works. 31.8, and C is 20 times the sine of 40 divided by the sine of 38, and I got 20.88, 20.9. So let's look at this. 31.8, 20.9. Double check here. This is the longest side. Yep. This will be shortest side, but not by much. 38 and 40 are pretty close. So this answer makes sense. Always check your answers. Okay, there's a problem with the law of sines, and that sometimes if you're given an angle and adjacent side and then the opposite side, you might run into problems. If this angle, how far this is opened up is known, that's set, that distance is set, and you know the length of this side, but you don't know the length of this side or how open this is, you could run into problems. Sometimes that side, if you know its length, but you don't know how long this is or how big that angle is, it could hang that way or it could hang that way and be the same length, right? You're keeping that angle, you're keeping the length of this adjacent side, and you're keeping the length of the opposite, but it could hit here or it could hit here. Or if it's too short, it may not even come all the way down. If this angle is too wide open for the length of that, or if just the length is too short for how big the angle is, right? I just said the same thing in two different ways. It could just never be able to make a triangle. The way to check that, if the side opposite the given angle, and this is if you have angle side side or side side angle, same thing. If the angle that's opposite is smaller than c times the sine, and I'll show you on the next page why. If it's less than, then it's never going to touch. But there's also ways to check this over here. Now, if this side is too long, longer than this side, then if it's the same length, then you'd have an isosceles triangle, right? But if it's longer than this one, it either sits over here, or if you swing it back the way this, if it's longer than C, it would be over here, and it would be that angle A wouldn't be inside your triangle. So if the A is longer than the C, then you've only got one triangle. That's all you have to check really. But I'll show you how to do it officially, checking it, and then how to actually in practice check it. All right, technically, you have side 1 and side 2. I'm going to put, I don't know why I didn't draw side 2 over here. Side 2 could be here, or it could be here. It could be straight down and make a right triangle, or it could be too short and not even make a triangle at all. So here's the deal. We have side 1 and we have side 2, but we don't know the length of this side, right? Let me make that dotted. Okay, so we know side 1, we know side 2, and we know angle A, which is opposite of side 2. All right, so H would be, if it was vertical, that would be the right triangle where side 1 is the hypotenuse. So if I have this angle and I have this side, the height of my triangle will be side 1, the hypotenuse, times the sine, which is opposite over hypotenuse, right? So you can find the height of the triangle. If side 2 is equal to this, then you have a right triangle. If side 2 is smaller than this, then he's just dangling there. He can't reach the bottom because your angle's too wide, okay? So if side 2 is less than H, there's no triangle. If side 2 is bigger than H, but smaller than side 1, then he could lay this way or he could lay this way, okay? If side 2 is bigger than H and bigger than C, then there's only one triangle because it couldn't swing back and forth. If it's too long, it would be out here or out here, which isn't a triangle with A on the inside, okay? So if it's bigger than side 1, then you're done. You can only make one triangle. So let's put this into practice. All right, in this example, we know that A is 40. We have the adjacent side is 60, and the opposite side is 50. So it's smaller than the adjacent side. So I want to find how high my triangle is. Well, the height will be, that's a right triangle, right? So this is opposite. So the opposite over the hypotenuse is the sine. So the hypotenuse times the sine will give me the height, right? So hold the phone, that's 40 degrees. Okay. So when you figure that out, you get that the height of the triangle is this. Well, my side is longer than that, but it's not as long as this. So it could lay this way or that way. So how do you solve this problem? Well, here's my law of sines. I'm going to use what I'm given. I know angle A, I know side A. I can find the sine of this angle because I know the side that's opposite. So I'm going to plug in the sine of 40 and side that's 50 and the side that's 60 and the sine of the angle that I'm looking for. So take this equation, multiply both sides by 60, and you get that your sine equals this stuff, only that's 50. So I stick that in my calculator, 60 times the sine of 40 equals divided by 50, and I get 0.7, pay attention, 0.7713, blah, 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 blah. I'm going to leave that in my calculator and do inverse sine to get the angle. And I get 50.47 dot, 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 dot. I'm just going to say that that's 50 degrees. Close enough, okay? That means that the third angle, because they all add to 180, my third angle, I'm sorry, don't mean to keep moving things around here. C1, angle C1. Right now I have 50 and angle A is 40, that makes 90. Oh, look, I've got a right triangle. It's not exact, it's more like it's 89.5, but that's okay. All right, I'm still not going to use the Pythagorean theorem, okay? This angle right here at the top in one way is a 50. Now, finding that third side, let's make this thing right here a little bit taller so we know it's an angle. And then I want to find side C, little c. I keep running out of room here. Little side C1 over the sine of angle C1 will equal the thing that I know. B is 50, sorry, A is 50, and the sine of angle A is 40. So C1, side C1 is 50 sine 90, which is 1, over sine 40, and I get that side C1 is, hold the phone here, 50. I'm going to stick in 89.5 instead of 90 for that angle, divided by the sine of 40, and I'm going to get side C1 is 77.78. So 77.8. Good. So that's the first answer. How do we get the second answer? Well, let's think about it. The sine is positive at the top. We got our first angle, B1 was 50, right? We have the same sine on the other side, okay? So what if this was the 50? That's the deal. So 180 minus 50 is going to give us our B2. So B2 is 180 minus 50. That angle right there is 130. Okay? And then you continue on. Smaller case B, or side B2, is the over sine of 130 equals A, sorry, I'm getting ahead of myself here. The thing that we know, side A over sine of angle A, and I get B2 equals 50 sine 130 over sine 40. So B2 is going to be, hold the phone, 50 times the sine of 130 equals divided by the sine of 40, and I get 59.58, so 59.6. And you can't use the Pythagorean theorem, right? Because this is not exactly, remember I used 89 point something on the last one for angle C. Let's see what angle C2 is here. C2, A is 40, B1 was 130, so 130 plus 40 is 170. Angle C2 is 10. Alrighty? So we have side C2 is to the sine of 10 as 50 is to the sine of 40. Multiply both sides by sine 10. And I'm going to get that side C2 equals 50 times the sine of 10 divided by the sine of 40, and I get 13.5. All right, that was involved, wasn't it? First, we checked to see if we had two triangles. Okay, now that works every time. Okay, but when we got B1 was 50 and we found C1, then we said, well, what if it went the other way? We said 180 minus this, we got 130. When we find this, and we'll do it every time, if we started with angle side. When we get this angle right here, the second possibility, and we add it to this one, if it's less than 180, then you know you have a second triangle. Okay, so if it's less than 180, we've got it. Remember, your calculator only gives the inverses in these two quadrants, all right? We're only going to be dealing with positive values because we're finding lengths. So you're going to get your inverse sine in quadrant 1, but we might be dealing with that other angle. You'll get theta, but you might have to figure it out for 180 minus. So you check it, see if it was that way, do these two angles add to more than 180? In that case, you've only got one triangle. If it doesn't add to more than 180, then you're good to go. Okay, let's check this one. We're given angle A is 40. We're given the side opposite the 40 degrees, side A, is 50. So we have this ratio here. We're given the length of this side. Notice that I have angle, side, side. We're given the length of this side. What we don't know is how long this is, how wide that swings out. We don't know that angle either. So, doing the law of sines, let's solve for this angle that's opposite the side we know. So I want my sines to be on top. So I've got sine of 40 is to the side opposite, the same way that the sine of side B, angle B, sorry, is to side 60. So I have sine of B equals 60 sine 40 over 50. I just multiplied both sides by 60. Now when I stick this in my calculator, 60 times the sine of 40 equals, divided by 50 divided by 50, sorry, I get 0.7714, blah, 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 right? Do the inverse of that, and I get B is 50.5, just like I did last time. Okay, it's the same problem, but this is the way, practically speaking, you're going to work them. Take this angle and this angle, add them together. A plus B is going to give me 90.5. Subtract that from 180. 90.5, you get 89.5, which is, this is B1, this is C1, and you solve for the lengths of the sides the same way. But the way you check to see if maybe you have a second triangle is you say this little deal right here, right? I got 50.5. But I need to check if this is 50.5, what is that? So 180 minus 50.5, you always need to do this if you have angle side side. That leaves me with 129.5 degrees. Now, add that to the 40 that you know. And I'm going to get 169.5, which is not bigger than 180. So I do have a second triangle. I have a second triangle. B2 is 129.5. C2, 129 and 40 is 169.5. Subtract that from 180 to get C2, and you're going to get what? 10.5. And then you solve for the other two sides using those two possible combinations of the angles. Notice that the 50.5, the triangle looks like this. For C2 and B2, this side right here is actually over here, and angle B is really big, angle C is really small. You see how that works? So you have the black triangle there, but you also have that triangle where this is 40, this is 10, close to it, and this is close to 130. And it all works out. All right? Now, next example. We have 40, and now notice that I changed the length of this opposite side to 30. So you'd start it the way you know. You have an angle and an opposite side. You have a side, you can find the opposite angle. So starting it out the same way, sine of B is to side B, the same way that the sine of 40 is to the side opposite the 40. Okay? So sine of B will equal 60 sine 40 over 30. And we stick that in the calculator and we get 60 times the sine of 40 divided by 30 is 1.29. Okay, first off, you can't have a sign equal to a number bigger than 1. Secondly, if you do the inverse sign of that in your calculator, you're going to get an error message. So this is no triangle. Why? Well, this side is shorter than this side, but that angle ended up being too wide. This side right here is kind of dangling and not reaching the bottom. It needed to be, from the way we worked it before, it needed to be at least 38 point something to reach the bottom, okay? So this side is not really there. It's not long enough. So, and the way you figure that out is you're going to get the sign of a number equals a number bigger than 1. And if you don't recognize that, when you do the inverse sign to find the angle, you'll get an error message on your calculator. And the reason is that doesn't exist. You can't have a sign greater than 1. Okay, let's practice using this for something useful here. Let's say we have a tree and it's on a hill. So now we're not talking about level ground anymore. This hill is at an angle of incline or an angle of elevation. That means from the horizontal angled up 7 degrees. But from where you're standing here at the end of the shadow, if you look straight up the hill at the sun, right? The sun is right here. The angle of elevation of the sun is at 40. All right. Remember, the shadow's laying straight down the hill, so there's not any cross anything. Okay. If we know the length of the shadow, we can figure out how tall the tree is. So we have this side, and we can find this interior angle here and solve for the height of the tree. But you always have to find the interior angle first. Okay. So, and there's other things that we know and we have to find out, right? We're using the law of sines. This side, the 20, is opposite that angle right here. So we have to figure that angle out as well. And we're going to use the fact that the tree is growing up straight. Let me do that in black. Right? And with the horizontal, that makes a right angle, okay? That means that there's a horizontal right here. And if the angle of the sun, angle of elevation, is 40, this is a horizontal and this is a horizontal, that line bisects. So if this is 40, so is this. So I said find theta, but we needed to find all the interior angles. Let me fix this. Find interior angles. Okay, now how are we going to find theta? Well, this bit is 7 and that whole thing is 40. That means that this is 40 minus 7, 33 degrees. This is 33 degrees. And this other interior angle, this is a vertical, this is a horizontal. If this is 40, then this is 50. Okay, so now we have a side and an opposite angle, and we have an angle and the opposite side is what we're looking for. We can also find this angle, but we don't need it. Okay, so here we go. Let's do the math. We want to solve for h, so I'm going to put it on top. H is across from the 33-degree angle, and that will match 20, which is across from the 50. So the height of my tree is 20 sine 33 over sine 50. And we're going to get that h equals, let's see, 20 in your calculator, 20 times sine of 33 divided by sine of 50, 14.2 feet. Does it make sense that the shadow is longer than the height of the tree? Well, yeah, remember if the sun is low in the sky, your shadows are longer. Plus, it's going down a hill, which is going to stretch it out a little farther as well. All right, last example. Two fire towers, 300 yards apart, spot a fire. They both see the same fire. From the line that connects the two towers, the fire is 45 degrees from Tower A and 65 degrees from Tower B. Now they can figure out how far away the fire is from each tower. So remember, we have to get internal angles. And I have this side is the side that I know, so I need this angle right here. Well, 45 and 65 is 110. Subtract from 180, and I get that this is 70 degrees right here. Okay? So now I've got side opposite. The distance from A is to the sine of the angle opposite that, the same way that 300 is to sine 70. Okay? And the distance from Tower B is related to the sine of its opposite angle, the same way that 300 is to sine of 70. You see the way these work, right? So the distance to Tower A is 300 sine 65 over sine 70. Stick it in your calculator. The distance from Tower B, 300 sine 45 over sine 70. Let's get these two values in the calculator. And distance A comes out to be 289.3. We are using yards. And the other distance is 225.7. Makes sense, right? Remember that the longest distance is opposite the greatest angle. 70 is the largest angle in the triangle. 300 is the longest side. The shortest distance should be across from the smallest angle. This angle is the smallest, and that distance is across from it. So it makes sense, and we're good to go. Work hard on this homework, okay? I'm not going to hit you too hard with the ambiguous case or the no triangle case, but you will run into it in the homework. Make sure you get this down because you're going to use it for the rest of the chapter. Go for it.